Hello, everyone. Welcome to Corda Accounts workshop. I'm Irina, and I will be presenting today with Sneha. And today we're going to talk about accounts and why we need them. And so in the beginning, I'll share some examples with you why we need accounts. I will also compare Corda network without accounts and with accounts. We will look at node architecture and how accounts transact with other accounts and with other nodes. After that, we will dive into flow structure, and Sneha will show you code examples. So let's begin. So why did we build accounts in the first place? What challenges accounts are trying to solve? So most CorDapp developers will want to represent their customers on the ledger as well. And that's a problem because the prevailing assumption when we first designed Corda was that a company runs on a node. So one node per company. Also, in order to join Corda network, you have to first get approval by a doorman, and operations side has to manually approve you. And imagine there are tens of thousands of people who wants to join. That's not scale very well. So let's see example. For example, a bank wants to represent the customers on Corda network. Each customer has its bank account in a bank, which is represented in as an account in a Corda network. So if we have Alice who runs a Corda node, and Alice, she has a bank, and she has 10 states in her vault. Vault is basically your database in node. And then running Corda without accounts, each of those states is implicitly owned by Alice. That is her entity, Alice Bank. So, however, if she runs accounts, she can say, well, I'm a known operator and I don't necessarily own or participate in those states. I'm doing it on behalf of customers. So, so she can set up 10 accounts and place those states in the accounts. So each account has one state in it. So, but she can see what states are owned by accounts. It's pretty simple. That's it. There is no more into it. Or there is another example with the supply chain application. So it's a huge issue at the moment. For example, we want to see example on procuring coffee and vegetables, where there are hundreds of farmers, and flow of supply chain starts from the farmer. We can't expect that every farmer will host a node on the Corda network. It's not very practical. This is where application of accounts is so powerful. We don't need these farmers to host a node. We will spin account for each farmer on our node. This is how you can scale out your Corda application by hosting these hundreds of farmers on a single node and save infrastructure costs. It's very simple to integrate accounts into existing application with the existing customer's ID. And I want to stress out that accounts are not complicated. It's just a library. It's just like another CorDapp with a lot of support that has to be added into a Corda core. It allows you simply to split a vault into multiple logical sub-vaults, and that's it. You still have one node. However, you can split your vault into multiple mini vaults. That's literally it. And you, as a node operator, can see the whole vault and mini vaults in it. So Corda accounts literally just provides scalability to your CorDapp. So let's see how accounts can be implemented in Corda. So now we can see a typical Corda network with these nodes and an identity manager who issues digital certificates to nodes. So till now, we only had those nodes. But now we have accounts that are hosted in the node. Each node can have multiple accounts, as we see here. These accounts give opportunity to scale up your application. This is what I was talking about in the supply chain. On previous slide, where one node can host now hundreds of accounts, which represents farmers. So one node can host multiple farmers. And this is represented on this layer. And then we can also see that identity over here, down, that live in existing Corda application. So each real life identity, for example, Sneha, she can have account on different nodes and can be represented by multiple nodes. And it's like one identity has bank accounts in different banks. For example, Sneha, she had account in one node and she has account in another node. So with that, we just bypass a common limitation of many distributed ledger technology system, which is that each node can only have one identity. So here we have a pictorial overview of the states, which are these black boxes. This is how it would work with accounts. So there is the vault of your node, this like a big outer box, and these black small boxes are your state objects. Without account, all states are live on one outer box. This is vault in one vault. With accounts, we see the node has some blocks of data that are squared with account 1 and account 2. And state belongs to these accounts. So this is where state is allocated. I want to stress that there is no physical separation, only logical separation, and all data live on the same database. In a sense, multiple accounts live in a node, and states can be mapped to those accounts. And or they can be directly mapped to the node, like these states. So that's a super simple idea. So how's the ways of users and identities can be represented on the Corda? And so way of a host can, this is a way that a host can represent its users. And but I want to stress out that accounts are not Corda identities. In the previous diagram, you saw that identity manager issues digital certificates to nodes. With accounts, it's not the case. So here you could see that it was Dorman was issuing certificates to nodes, but not to accounts. So that there is no certificates by Dorman, and identities live within a context of a host node. So physical vault isolation is not supported, so everybody can see everything, but facility to provide permissioning for accounts exists and have to be handled by CorDapp developer at application level. If you apply permissioning at application level layer, it can be easily handled. All account information and keys are all stored in the hosted node. The node operator has visibility to everything. And at the end of the day, all the data is still stored in the node's database. So what we can do with accounts libraries? With accounts, a simple 3-node network can operate with much more flexibility. So let's assume that node A has 4 accounts and node C has 3 accounts. So now with accounts library, it's possible to transact between accounts to node and vice versa. It's possible to transact between accounts that live on different nodes and vice versa. And it's also there is also possibility to transact between accounts that live on the same node. So what we learned so far is that accounts is just like a very simple library that allows you to split your vault into multiple mini vaults. It allows you to represent your customers in a node. So you can split your database into multiple small mini databases, but you as a node operator can see everything, and the data still lives in a node's vault. Accounts are not visible via address book, and only node that hosts accounts is visible. It's like if I live in a flat in a house, and that on a map, I'm discoverable by house address. Flat is just additional information to filter me out of all other flats in my building. But it's exactly the same with accounts. Everyone only see the nodes, but no one can see accounts. So this is additional information. And now I will pass it to Sneha.
Thanks, Arena. That was super helpful. Now, hi guys, my name is Neha. So let's quickly jump on and let's move on to the technical aspects of accounts. So let me share my screen. Okay, cool. So now let's quickly talk about account info and account service. And once we've spoken about account info and account service, we'll move on to the actual flows of accounts. So let me open my idea and let's talk a bit about account info. So an account in Corda, you can say, is actually represented by an account info object. So an account has 3 things associated with it. An account has a name associated with it. It has a host associated with it. And also it has an identifier associated with it. Now, this identifier is of type UUID. So you can safely assume that, excuse me, you can safely assume that this account identifier, this account ID basically is unique at a network level. Again, this account info is, you can say it's kind of similar to node info. It's just that it is not discoverable via network map service similar to node info. Also, let's say that account 1 is hosted on node A and account 2 is hosted on node B. So for these 2 accounts to interact with each other, for these 2 accounts which are hosted on separate nodes, for these 2 accounts hosted on separate nodes to interact with each other, these accounts must be aware of each other. So what happens is usually that the nodes basically share this account info with the counterparties so that the nodes or rather the accounts on different nodes are aware of each other. Once the nodes and the accounts are aware of each other, then the accounts present on different nodes will be able to interact with each other. Now there are different flows to do this. So for example, to actually share the account info, you can use the share account info flow. And also to request the account info, you can use request account info. So basically at the end of the day, a node can either share the account info with the counterparty with which it wishes to interact with, or there's another way also, a node can also request an account info from the counterparty. So the basic idea is that a node and an account hosted on a node should be aware of an account hosted on other node, so that this account will be able to transact with that particular account. So that's the idea. So quickly again, what I said, we spoke about how account can be represented in the database. So basically it's represented using an account info object. An account has a name, a host, and an identifier associated with it. And also for accounts which are hosted on different nodes, these different nodes need to be aware of the accounts hosted on different nodes. If the accounts are aware of each other, then only they'll be able to transact with each other. So just keep these two things in mind. Now we'll see how to actually share the account info with the counterparties as we move on. So moving on to the next part, which is account service. So let's see account service. So account service is basically a service class, or you can say it provides you a set of APIs which are useful for the CorDapp developers who work on accounts. So this provides an APIs which can be used, and these are kind of you can say these are helper methods which can be used by the CorDapp developers. So for example, given the identifier of the account, you would be able to retrieve the account info from the database or from the account. So these are, given the public key, you can get the account ID for the key, or there are methods or there are APIs which you can use. So for example, the create account lets you create an account in a node. So these are the different ways, or these are the different APIs which are available. So these are the different helper methods. So you'll actually start using them when you actually start using Corda accounts. Now moving on. Yeah. So so if you look at this particular diagram, then this particular diagram, basically this slide on a very high level, it talks about typical steps or the basic flow of an accounts Corda app. So the leftmost part, actually, it talks about two things. It talks about how you can create accounts and how you can share these accounts with the counterparties. The middle portion, it talks about how accounts transact with each other, or rather how can accounts transact with each other. And the last part talks about the data retrieval. So basically, the last part talks about how states mapped to accounts can be retrieved from the database. Okay, so we'll look at all these three verticals. So let's go step by step. Let's first only focus on the first vertical, which is account creation and account sharing. Once we've seen that, we'll move on to the flow, and we'll execute a flow which will show us how accounts interact with each other. And then we'll move on to the data retrieval part. So yeah, so let's move on to idea. So for this particular session, what I'm going to do is I'm going to use this very small application, which is the Bootcamp Corda app. We use normally for our bootcamps usually, but I've made some slight changes to this. And instead of having nodes interact with each other, now we have accounts who can interact with each other. So this is basically a token issuance Corda app. And in this tokens issuance Corda app, what we're going to do is we are going to issue a token. We're going to issue a token state from one account to the other account. Okay. So in our earlier bootcamp Corda, what we used to do is we used to issue a token from one node to the other node. Now here in this Corda app, what we're going to do is, again, we are going to issue a token state from one account to the other account. Again, there are few things like a few basic things which are required to build any Corda app. So we have the token state, token contract, and then we have the token issuance flow. So these are the three basic elements which I've written for this particular code. We also have create and share account, which talk about this first vertical, that is account creation and sharing. Without talking much, let's do one thing. Yeah, so before even going into any flow, what I've done is I have built this project and I have deployed these party A node and party B node locally. I also have these party A node and party B node. These are also connected to an in-memory H2 database. And I've started this in-memory H2 database on my UI. So you can see that this is party A, which is connected, which is 42. And this is party B, which is connected, which is 43. So I have the entire project set up, and now I think we are good to go. So let's move on, and let's first go to our very first flow, which is the create and the share account flow. So as we spoke earlier, for accounts to transact with each other, the accounts must be aware of each other. Again, for accounts hosted on different nodes to transact with each other, they must be aware of each other. To be aware of each other, a node can use the share account info flow to share the account info details with the counterparty. When I say share the account details, I mean sharing of account info detail only. So we saw that account info consists of the name, host, and the identifier. So when I say share account info details, I mean sharing of these three things with the counterparties. Before even actually we share the account details, there must be obviously an account which has to be created in the database, right? So the very first flow which we will call the create account flow. This flow will actually create the account on the parties database. So this flow, create account flow, it takes in an account name as the parameter, and it returns me a state and ref to this account info. Once I've created this account, I'm going to share this same account with the counterparty whom I wish to interact with. So what we are going to do is we've deployed two nodes, party A and party B. And what we're going to do is we are going to create two accounts. One account we'll create on party A node, and one account we'll create on party B node. So let's say that I create an issuer account on party A node, and we'll create an owner account on party B node. And then when we'll execute our flow, we'll issue a token from issuer account to owner account. That is an account, we'll issue a token from account hosted on party A node to account hosted on party B node. So let's do one thing. Let's execute this flow. So I'm going to copy this flow and I'm going to paste it on party A side. So this is the create and share account flow. It takes in two parameters. So I'm going to execute this flow on party A. It takes in the account name, which has to be created on party A side. And it also takes in the parameter, which says that party to share account info with. So I'm going to share this account one on party A node. And I'm also going to share the same account with the counterparty, which is party B. So let me hit this flow and let it execute. We'll do the same thing from party B side as well. So the flow has executed and hence account one has successfully been created on party A side, and this is also shared to party B node. Now let's go to party B node and let's execute the same flow on party B side. So on party B side, what we are doing is we are creating account 2 and we are sharing this account info with the counterparty, which is party A node. So let me execute this flow. So this flow has executed. So because of this, account 2 has been created and it has been shared with the counterparty. So let's go and check the database. So in the database, an account info is represented or rather stored in an accounts table. So let's hit this table. Let's see, let's do a select star from accounts to see what data is it has. So let's do this on party A side, and also let's do this on party B side. So till this executes, let's also run a similar query from the terminal. So let's hit the account info state on party A side, and let's see what's the output. So on party A side, I have two accounts, account 1 and account 2. Account 1 was created by party A, and this was shared with party B. And account 2 was created by party B. So the host is party B. And then this was party B shared this with party A. And that's why party A also has this information, this account information of account 2. If we run this similar thing on party B side, we should see that on party B side as well, we have an account 1, which is hosted, which was hosted by party A, and party A had shared this account info with party B. And that's why party B also has all these three details of account 1. We also have account 2 created by party B, and that's why we see this account info in party B as well. Now, if I again go back and look into the database, so this is basically the accounts table, which again has three things which I told you. It has a name. So any account has a name, ID, and host associated with it. So this is party A node. So party A node has account 1, and it also says that the host is party A, and this is the identifier associated with this account. It also has account 2, which was shared by party B, with this as its identifier, and this as the party B, which is the host of account 2. If we look at party B's database, yeah, so if we look at party B's database as well, so we have account 1, which is hosted by party A, and account 2, which is hosted by party B. So we have the similar view. So now if you look, we have basically have the accounts created. We've created account 1 on party A, we've created account 2 on party B. We've also shared the account info with the counterparties. Now, account 1 on party A is ready to transact with account 2 hosted on party B. So this is how this is how you create accounts, and this is how you share account info from one party to the other party. And this is how accounts are aware of each other, hosted on different nodes. And now, because of this, accounts on different nodes can easily transact with each other. Now we've completed the first part. Now let's move on to the second part, which talks about executing a flow, or rather it talks about how accounts can interact with each other. So let's move on to the second flow, which is the token issuance flow. Now this tokens issuance flow, before even going to a tokens issuance flow, let's talk about the basic three things. Like, let's talk about the token state and the token contract as well. So in the token contract, till now, we've used Corda to make sure that what you see is what I see. Until now, we've seen that where you and I in this what you see is what I see were nodes till now. So where you and I were nodes till now. But with accounts, what we aim to achieve is, we aim to achieve that what you see is what I see. In this, what you see is what I see. You and I are actually accounts, and they are not nodes. So we aim to achieve that what you see is what I see. In this, you and I are accounts hosted on individual nodes rather than nodes themselves. So, so let's take a look at this token state. Now, if you see, this token state has two properties, the issuer and owner. Now, issuer and owner, for a normal token state, it used to be a node, or rather a party class. But now the issuer and owner are represented using anonymous party. So basically, these issuers and owners in this token state will no longer be nodes, but they are going to be accounts. And what we're going to do is this, we are going to issue a token from an issuer account to an owner account. Now, as to an issuer account, from an issuer account to an owner account. Now, as we know that there's a participant field in the token state. And this participant field, if you see, it is of type abstract party. Now, instead of adding the party class, which implements the abstract party, what we are going to do is we are going to add the anonymous party to the participant field. So party class has a Corda X500 name associated with it, along with a public key. So basically a party class has got two things. It has a public key and it has a Corda X500 name. And the anonymous party class has only one field, which is the public key. So basically, we've already spoken about this, I think, earlier, that a party is usually represented by a public key and a Codex 500 name, because the identity manager, it issues a digital certificate to a node, and a party is in itself, it's a true identity. It has a legal name associated with it, and it has a certificate associated with it. It has a Codex 500 name associated with it. But we've also spoken that accounts are rather different. They're not true identities, or you can say they're identities within the context of a node. So they do not have any certificates as such issued by the doorman or the identity manager. And because of this, they're not actually associated with any Corda X500 name. So it totally makes sense for accounts to be represented by anonymous party. So this is how in Corda, we represent accounts using an anonymous party. That is, we represent accounts using a public key. That is, a public key is usually mapped to an account. And we use this public key to participate in this particular state. So this is how a public key is mapped to a particular state. And this is how this state then eventually gets mapped to that particular account. So again, to just quickly repeat what I said, a state is, so this state basically gets associated with an account using a public key. So basically, there are two things to keep in mind. An account is mapped to a public key using this anonymous party, and a state is also mapped to a public key because it depends which public key is used to participate in this state. So basically, there are again two things. An account is mapped to a public key, and a state is also mapped to a public key. And this is how a state is mapped to an account. So basically, a state, you can say, is mapped to an account using a public key. Now, please note that here we are using confidential identities to actually create these public-private key pairs. So Accounts SDK heavily relies on confidential identities to create these key pairs. Now moving on, and let's also talk a bit now about token contract. So we saw the token state. Now quickly to summarize, we saw token state and we saw how now issuer and owner are no longer nodes, but they are anonymous parties. That is, they are accounts. An anonymous party is used to represent an account. An anonymous party has just one field, which is the public key. Therefore, an account is represented using an anonymous party, or an account is represented using a public key. Also, we saw the participant field, and also we saw that how accounts, how the public keys are used to participate in this token state. And because of this, how a token state or how a state exactly maps to a particular account. Now, having said that, let's move on to the token contract. So token contract is a typical contract which implements the contract interface. we will use this verify method to validate the transaction or to validate the transaction proposal. Our transaction proposal is going to be a token issuance proposal, where we are going to issue a token from one account to other account. So this verify method will verify this particular transaction proposal or this particular token issuance proposal. So this is a typical contract where you can write all the rules and constraints which you want to make sure and you want to validate the transaction against. So this is a typical contract, so I'm not going to go into much detail into that. And now we'll quickly move on to the tokens issuance flow. So now this is a complete, you can say that this is a typical flow. And what we are going to do in this flow is we are going to issue a token state, and the token state is going to be issued from the issuer account to the owner account. Okay. Now let's go step by step and let's try to understand, before executing this flow, let's try to understand basically what this flow is trying to do. So in the very first two steps, and also I'm going to issue this flow from party A side. Okay. So, let's look at the very first two steps. So the very first two steps, they talk about retrieving account info from the database. And once I have the account info with me, so this account info basically will be retrieved from the database table, account database table, which I showed you. Once I have the account info with me, what I'm going to do is I'm going to call request key for account, and this will actually give me a public key. So we spoke earlier, right, that account is represented using an anonymous party, an account is represented using a public key, and then we use this public key to actually participate in a state, and this is how a state is linked to an account. So if we wish to actually have a public key, and if we wish that a public key should be mapped to an account, and if we wish that we should use this public key to participate in a state so that the state can be mapped to an account, we first need to have this public key, right? We first need to have a public key to account ID mapping, right? So these two things, that is creating public key and having the public key to account ID mapping, these two things are done by request key for account flow. So the next step, what I'm going to do is I'm going to call the request key for account, which will create a key for, let's say, issuer account, and it will map this key to the account ID, to the issuer's account ID, and then it will simply return this public key to me. Once I have this public key with me, I can simply use it to participate in any state. And this is how this particular state will get mapped to this particular account. Okay. So again, what I'm doing is I'm retrieving the account info. I am getting a key. I'm getting a public key from request key for account. Request key for account will create a public private key pair. It'll assign this public key to this particular account. It will not only create the key, but it will also save the key to account ID mapping in the database, and it will return me this public key. Once I have this public key, I'm going to use this to participate in the token state. And this is how the token state will get mapped to this particular public key. And because my account is also mapped to this particular public key, this is how a token state will be mapped to my account. Okay. So that's it. So we just require two mappings, a public key to account ID mapping and a token state to public key mapping. So this is how a token state can be mapped to an account. Once I have created the transaction builder and added the token state, we will add the command in which I will specify that both the accounts will sign this particular transaction. We will call the verify method, which will execute the contract. And once we call the verify method, the first we will have the issuer account who will sign the transaction. And then we will move on and we'll use the collect signatures flow to go to the owner's account, which is hosted on party B side. And we will collect signatures from the owner account. Now, please note that though I say that I'll go to the owner and ask him to sign, and I'll ask the issuer account to sign, though I say this, please note that accounts are not true identities. They do not have a certificate associated with them. So ideally, what will happen is the accounts are basically hosted on individual nodes, right? So in a sense, these nodes actually sign this particular transaction on behalf of the account. Okay, so it is actually the node who's signing using the keys which are associated with accounts on behalf of the accounts. So we call the collect signatures flow. We pass in the third parameter specifying that the issuer has already signed this particular transaction, and please collect signatures from the remaining parties. So this is how the collect signatures flow is called. And lastly, we call the finality flow. What finality flow will do is finality flow will again save this token state on and it will map it to issuer's account and owner's account. When I say it will map it to issuer's and owner's account, I mean that we saw in this in earlier diagram, right? That these are the two logical subvaults. So token state will be mapped over here, as well as token state will be mapped over here as well. So now moving on, let's execute this flow and let's see the output in the database.
Sneha, there are a couple of questions. So first one from Rushev, where he asked if you could please give example of how to use request accounts info. In particular, how would how the requester obtain the accounts identifier to pass to the request account info flow?
Okay.
How to use request account info?
Request account info. Okay, please give an example of how to use request account info. Okay. So there's no request account, but I have used request key for account. So what I'm doing is I am using a request key for account to obtain the keys associated with the account.
Okay. And another question, is a new key pair generated at each transaction?
So whenever I call request key for account, right? So whenever I call request key for account, a new key pair will be generated. Now there are two aspects to this. You can always keep using this key for each and every transaction, or what you can do is for each and every transaction, you can call request key for account each time, which will generate new key pairs, which will generate new public key, private key, and every time it will assign a new public key to an account, and you can use this new public key always to participate in the transaction. I would highly recommend you to use the second approach, where we use a new key pair is generated every time while creating a transaction. Why? Because it might happen that, let's say, after a year, you are still trying to use a key. Let's say that party B had created a key for owner, and it had shared this public key with us. And let's say that we are trying to use the same key which was created 1 year back, and for some reason on party B side, somebody or the party owner, he deleted this key pair. So there can be such issues that the key pair doesn't exist anymore on the other node. So it's better to use new key pairs every time whenever you do a transaction. Okay, so
Yeah, that's it. Thank you.
yeah, cool. So let's move on now, and let me execute this particular flow. So the token issuance flow, let me go and first let me execute this flow on party A side. So this is party A. And what we are going to do is we're going to pass two things. So the issuer is going to be account 1 and the owner is going to be account 2. And the amount is going to be 10. So let's execute this flow. So the flow is started and the flow is done. The flow is successfully executed. So with this flow, what has happened is one token state is issued from account 1, which is the issuer account, to account 2, which is the owner account, which is hosted on party B side. So a token state is now issued from issuer to owner, from party A to party B. And this is how now a token state will be mapped to an account, to account 1 as well as to account 2, right? Now let's look into the database, and then let's get into a few details which I'd like to highlight here. So let's look at public key hash to external ID map table as well. So this is for party A and this is for party B. So till this executes, let me talk a bit about how the request key for account works, okay? So for request key for account, how this works is, so let's say that if I execute this flow, so if I'm executing the tokens issuance flow, which has this particular flow, and let's say that I'm executing this flow from party A side. So what this will do is, when I execute it from the party A side, it will first check that whether this issuer account is hosted on party A or not. If it is hosted on party A node, it will create a key, it will map it to an account, and it will return me this particular key. Okay, very simple. It checks if the account is hosted on similar node. It goes, it creates a key pair, and it maps this key, public key, to an account, and it saves this mapping, this key to account ID mapping in the database, and it sends back this public key to us. Okay, that's it. So if you look into the database for party A side, you would see that a new key pair was generated and a mapping from public key to account ID is done. This mapping is saved in this table in this database, and we simply get this public key for signing. So now if you see that, so this external identifier is nothing but 29250 is nothing but the identifier, which is nothing but account 1. So now here you can see that the public key to account ID mapping is available for account 1. Also, let's take a look at account 2. So now how does this work if an account is not hosted on the same node on which we fire this flow? So how request key for account works is, if this account is not present on the same node, this particular flow will go to party B node on which this account is hosted. Party B node will create this, will do the same thing. It will generate a key pair. It will map this key to the account. It will save this mapping in its database, and then it will simply return this mapping to us. So this is from party B side, and party B side has created a mapping for account 2, and this mapping has been returned to us. Okay. So, but if you look from a different perspective, you see that party A now is aware of the mapping for account 1 as well as for account 2. But if you look from party B side, hence it is party B side is aware of only the mapping for account 1, account 2, which is an account hosted on its node, but it is not aware of mapping of account 1. It is not aware of what public key was used to participate in the token state, or what public key maps to account 1. This guy is completely unaware of this particular mapping. So that's why now if I try to execute one more flow, which is the query by account. So what this flow does is, this will query the database for a token state associated with account. So let's try to first run this flow. So let's try to run this flow on party A side. So on party A side, I'll see what, I'll try to retrieve the token state which is linked to account 1. So let's hit this. So yes, I retrieve the token state properly on account A side. Also, if I try to do the same thing for account 2 on party A side, Here also, I'm properly able to retrieve the token state associated with account 2 as well on party A side. Now, why did we were able to successfully execute or retrieve the token state available with both the accounts? Because in the database, we have on the party A side, we have all the mappings required for both the accounts. We have the public key to external ID mapping, and also there are other tables where we have the correct mapping from the public key to token state as well. So that's why we also have correct mappings from the token state to account ID as well. So that's why we are correctly able to retrieve these states. But if I try to run the similar flow on party B side, so let's run it first for account 1. So this on account for account 1 on party B side, it says that no token state has been mapped to this account. So it asks us to either use share state with account flow or sync key mapping, which will do the syncing of this particular mapping. So as we saw that on party B for account 1, we do not have a mapping saved in the database. So as such, party B is not aware of public key to external ID mapping, and it is also not aware of the token state to external ID mapping. So that's why it is completely unaware of whether this particular state belongs to account 1 or not. And that's why what we do is to overcome these kind of issues, what we do is we call the share state with accounts from party A side. And this is used to actually sync completely the keys. And this flow basically does two things. It will sync the keys, it will sync the key to account ID mapping from party A side to party B side. Because of this, accounts hosted on different nodes will be in sync, and also it will also sync the state to account ID mapping. So the states which are mapped to accounts on party A side will be completely synced with the states to account ID mapping on party B side as well. So party B side will also have, you can say, a similar view or a sync, or they'll be completely in sync with the other nodes as well. So let's try to again execute this uh, from account 2 perspective. So from account 2 also, we are getting the similar issue that the issuer key to account ID mapping is not available on the party B side, and hence we are not able to retrieve the token state. But since the owner, which is account 2 mapping, is available, we are able to retrieve this particular state. So we are able to retrieve this particular state for which the mapping is available. So in short, if the correct mappings from the public key to external ID or from the token state to external ID, if these correct mappings are not available in the database, then you might have then you might want to call this share state with accounts flow. So now let's do that. Let's call the share state with accounts flow, and let's try to do the same thing again. So if we look into the database and we try to call the another flow, so this particular flow, basically this flow is similar to the earlier flow which we did. I've just added this one line. This one line, what we are going to do from a party A side is, once we've created the token state, we are going to share state and sync accounts. That is, we are going to share this key mapping. We are going to share this key mapping with party B, and we are also going to share the token state to account ID mapping from party A to party B. And because of this, account 1 hosted on party A side will be completely in sync with account 1 present on party B side, and similarly for account 2 as well. So now let's try to execute this flow. So to execute and to show how this works, I'm going to create 2 more accounts. So I'm going to create account 5, and we're going to follow the similar steps. So account 5 will be created on party A side, and it will be shared with party B. Similarly, we will create an account named account 6 on party B side, and we will share it with party A. And then what we'll do is we will run this sync flow, and this sync flow, we'll run it from party A side. Once this flow is complete, let's hit the database and let's check the mappings now. So till the database query executes, let's hit the query by account flow, which will tell us what is the token state associated with this account. So on party A, as it is, it's going to work for account 5 and for account 6. So we get a token state associated with account 5. We also are able to retrieve the token state associated with account 6. Now, if we try to execute the same thing from party B node, if we try to see the token state associated with account 5, yes, now we are correctly able to retrieve the token state associated with account 5. And we are also able to retrieve the token state associated with account 6. Now, if we look into the database now, on party A side, so these two entries were for account 1 and 2, and these two entries are now for account 5 and account 6. So on party A, as it is, there was no issue. And now, since we've called the share state and sync accounts from party A side to party B side, now these are the two entries which are there because of the share state and sync accounts. So these are the two entries which correspond to 2297 and C3E. So these are the two entries. These two external IDs represent account 5 and account 6. And now accounts, or rather account 5 and account 6 hosted on party B side as well, are completely in sync with accounts hosted on party A side as well. And because the accounts are now in sync, the states to account mapping is also in sync, we are correctly able to retrieve data, or we are correctly able to retrieve states from the database. So having said that, I'm done with the coding part. And now I'm going to take the remaining questions. Before I take remaining questions, let's do a quick recap where we saw that how accounts are represented using anonymous party and not party class, and how an anonymous party is nothing but a public key. And because of this, how accounts are represented using public key. And we also saw that how public keys are used to participate in the state. And this is how accounts are mapped to a particular state. Again, there can be one-to-many mapping from one account to public key. So many public keys can be associated with one account, but one public key is also
Okay.
use the share state and sync accounts.
Seha, Seha, if you could please repeat the last minute, there was internet connection problem.
Okay. Yeah. So regarding the quick recap, right?
Yeah. If you could repeat just like two last bullet points.
Okay. So we saw that how the signing, when it comes to actual signing, it is actually the host who signs the transaction on behalf of the accounts. And we also saw how the share state and sync accounts work, and how it is used to actually sync account to token account to the state mapping and account to the key mapping, how it is used to sync these two things on the accounts hosted on different nodes. So yeah, so moving on, these are the 3 samples which are available on GitHub. So guys, feel free to go and check them out, clone them to your repository, try them out. And if you have any questions, feel free to contact us on Slack channel. So these first 2 applications talk about supply chain and tic-tac-toe, where these completely focus on accounts, and they show you how accounts can be used to build these kind of applications. The last application, which is the World Cup ticket booking, it's also an interesting application which shows you how accounts can be integrated with tokens. So our next workshop is on the same day, same time, that is 2 p.m. London time. So it's going to be completely focused on tokens SDK. It's going to be an exciting workshop. So guys, do register and do join us on June 25th as well. Again, I would highly recommend you guys to go and take a look at the training.corda.net. Here we have a completely free training available, and especially accounts. I would highly recommend you guys to go and check out the accounts training, because it's literally awesome. I've gone and looked at it many times, and the examples which they've shown over there are simply useful. So the entire training is based on few examples, and all the concepts are kind of explained using these examples. So it's pretty cool. So just go and look at training.corda.net. Also, if you have any questions, any queries regarding accounts, regarding anything, any concept related to Corda, feel free to contact us on slack.corda.net. Join Slack and join the Corda Ledger channel. We all the entire DevRel team is available there. We also have the engineering team who's present on the Slack as well. Do visit docs.corda.net, which in general talks about all the concepts of Corda. Again, all the samples are present on github.com/Corda. So you can go and take a look at all the samples as well. For any other queries, if you wish, you can contact us at devrel@r3.com, and also feel free to, and also please follow us on Twitter as well. Now coming, before I end quickly, I'm going to pause for like 10 minutes and let me look if I have any more questions. So, so let's start from here. So I have read that we should not combine nodes with accounts and nodes without accounts to avoid problems. But if we use in such a way due to requirements, what are the things we watch to avoid problems? So it really depends on the use case which you're doing. So for example, when I had created the tokens and accounts example, there are certain conditions where you had to use node to account mapping. So it really depends on the use case. So there aren't any such specific areas which I can highlight as of now. But yeah, it is highly recommended that don't mix accounts and non-accounts. So yeah, if you face any problems, you get back to me and we can look into that. So it would be helpful if we can get an example of a flow between a single account, node A and node B. So the last example which I showed, the World Cup scenarios. So it shows you how to transact between accounts hosted on same node, and also how to transact between accounts hosted on different nodes. So feel free to take a look at that, and again get back to me if you have any more questions. Where can I find this repository? So the repository link is shared on the second last slide which I just showed. If we have two accounts in one node and one account in another node, if name of account in both nodes have same name, how do we resolve the confusion of which node does that account belong to? So usually an account is identified not only using name but using these three parameters. So you have an account associated with an ID, with the name and the host. So if so there are two things to it. If one account has the same name hosted on one single node, then by default Corda won't allow you to create a new account having the same name on the same node. But yes, of course, you can have a different an account hosted on different node having the same name. So you can basically either use just the identifier instead of names, or you can use the host name to identify whether this particular account belongs to, you know, belongs to this party or the other party. If we consider a node representing a legal entity and accounts representing individuals, synchronization would mean each legal entities will know what are the individuals on their counterparties. So see, it really depends on your use case, because if these accounts have to interact with each other, they should know at least these three things. That is, they should know what's the name of the account, what's the host, and what's the ID. So we are not sharing, or we are not synchronizing anything else. We are not synchronizing the private keys or anything else. But at least to have an, if you need to interact with each that particular account, you will have to know its very basic, these basic details at least, right? So for that, synchronization is required. So how do dynamic key pairs impact looking up history transaction on the ledger for account? How can you look up a historic transaction if the key was temporary and was disposed of already? Yeah, that's a very good question, actually. I actually haven't thought about this, but yeah, let me get back to you on this question. So that's why I always recommend actually to use the second approach, that is to use new key pairs every time. But yeah, let me get back to you on the last question. Okay, I think we are done with all the questions. So I think we're also over time. I think we're 6 minutes over time. So with this, I'll love to now take a pause and take a break, and I'll love to end this session now. So thank you all for joining us, and it was a very good session. And thanks for all the questions. We really enjoyed it. So hope to catch you all for the next boot camp, which is the token boot camp. And of course, guys, do contact us on Slack for any questions, for any queries. Okay. Thanks a lot. Thank you.
Thank you. Bye.